Understanding trigonometric ratios, communication question 6. How can you find cosine of an angle if the sine of that angle is known? Apply your explanation to find sine of A if cos of A is given to 3 over 5. Well, in this question part 1 is different from part 2, but they are related. So we'll solve them. So first we'll try to understand how to find cosine of an angle if sine of an angle is known, and then the second part actually could have been a typing error while I'm doing it. But in any case, apply your explanation to find sine of A if cosine is given, right? So actually we are given cosine, we need to find sine. So either way, both things are important. So the thing here is, if one of the trigonometric ratios is given, how to find the other one? That is what the real question is, correct? So that's what we'll answer here. So let's make our triangle here. So I normally draw 3 lines. It's easier flow of lines, which gives you a better neat and clean triangle, right? So here is our right angle triangle. Now let us say we know sine, and let's call this angle as A, and the sides opposite will be, let me see, ABC is our triangle, and therefore the sides are small a, b, and c, correct? So that is how we are working, and that's the triangle angle A we are interested in. Now in general, let us say we know sine of A. So if you know sine of A, that means you know the ratio A and B, right? You know A and B. Then you can use Pythagorean theorem to find C, correct? Now you know c square is equals to a square plus b square, or c is equals to square root of a square plus b square. Then you know c, right? Now, okay, so we knew sine of A, that means we know the ratio A over C rather, right? So if you know A and C, then you can find the other side, which is B, right? So you can use the same Pythagorean relation and find what is B. Okay, so B will be equals to C square minus A square, correct? Like that. So there are many different situations. So what I'm trying to answer here is that it doesn't matter if you know any one of the trigonometric ratio, whether it is sine, cosine, or tangent, then you can find all others. So we are trying to generalize it here, right? So yeah, so let's say that if you know sine, let's say we know sine, right? Sine of A, that means in this triangle we know A over C. That means we know A and C. So if A and C is known to us, we can always find what B is, right? So in that case, B should be equals to square root of C square minus A square. So we know our B. Now when you know 3 sides of a triangle, you can find any trigonometric ratio, correct? Now let's say you know tan A, for example. So tan A is A over B, right? A over B. So we need to find what C is. You can find C using Pythagorean identity, and that will be A square plus B square square root. Similarly, if you know cos of A, right? Cos of A is B over C, correct? B over C. Okay, B over C. Then you need to find what A is. So A will be equal to square root of C square minus A square. So A will be C square minus B square. The 2 known things, right? In our case, let's solve it now. And so we just generalize the first statement. It doesn't really matter. Let's take it like this. How can you find the other trigonometric ratios known if one of them is known? Any one of them is known, right? Think like this now. Well, and then the second part makes sense. Apply your explanation to find sine A if cos A is 3 over 5. So cos A is 3 over 5. Then make your triangle like this and say, well, cos is adjacent over hypotenuse. So this side is 3 and this side is 5. Now I need to find the opposite side, A. So, well, A should be, so what we have here is cos A is given to us, and that is 3 over 5, correct? So you can compare B is 3, C is 5. That's what we wrote. Now A should be equal to 5 square minus 3 square square root, correct? So we say, well, A is equals to 5 square, which is 25, minus 3 square, which is 9 square root. And this is 25 minus 9 is 16, and square root of 16 is 4, correct? So that is your answer. So this is 4. We find, well, a should be equal to 4. Now once you know a, then it is so easy to write all our trigonometric ratios, correct? So we say, well, now in this particular case, sine a should be equal to what? Sine a is opposite over hypotenuse, so it is 4 over 5. And tan a, I know it is not asked for, let me write down 4 over 3, correct? 4 over 3. So this is the way you should see the problem. So we are trying to teach you a method that if any one of the trigonometric ratios is given to you, then all of this could be found. So that is one solution of doing this. The other way is, I'm running out of space here, so I'll just make a small room here to tell you the alternate solution. It's kind of important for me to explain you, and that is, when you are given a ratio, for example here, we know cos of A equals to 3 over 5. Then use your calculator, correct? Use your calculator and find what angle A is. So we say angle A is equals to cos inverse of 3 over 5. Cos inverse within brackets 3 over 5. So once you do that, then you know angle A, correct? Now if you know angle A, then you can find sine of that angle, cosine of that angle, tangent of that angle, and all of the trigonometric ratios. So that is an alternate method of doing the same thing, right? We are still not there at this stage because I'm going to take it up and after explaining you what these things are, and therefore in this video I have not gone into that solution, okay? But that is a solution for you to explore, okay? Thank you.